Thank you, Dr. Ritchie. Our first panel is entitled Enhancing Collections. And we have 3 speakers in this panel. We're going to allow the speakers to enjoy the other presentations as a member of the audience so they can see the screens. And then after all 3 have presented, we will ask them to come up and take part in a roundtable discussion and question and answer session. Our first speaker is Dr. Adam King, Research Associate Professor at the Institute of Archaeology and Anthropology at the University of South Carolina. Dr. King has ongoing research projects exploring the development of Mississippian communities in the Etowah River Valley of northwestern Georgia and the middle Savannah River Valley of the Georgia-South Carolina border. His research attempts to understand how Mississippian societies in these areas came into being and changed over the course of their individual histories, using traditional archaeological excavation coupled with remote sensing, the exploration of ancient imagery, and absorbed residue studies. The title of his paper is Exploring Native American Ritual Beverages Through Absorbed Residue Studies. Dr. King.
Thank you, Dr. King. I appreciate the opportunity to be here. Dwayne and I aren't kin, but I will claim him in a second. I'm here, I'm an archaeologist, and I can say from the perspective of archaeology, technology has and continues to change the way we do things and the way we learn about the past. And my talk today is about a research project that we've done with material here from the Gilcrease. Mississippian is a time period and it's a cultural adaptation in the American Southeast and Midwest that dates from 900 to 1600 AD. And we came to the Gilcrease to sample some of the Native American collections looking for evidence of ritual beverages. Before I talk about our research project and what we learned, both in terms of the beverages and about the project itself, talking about pivots, I want to talk a little bit about how absorbed residue studies work, because it builds into where our study worked and where we had to pivot. First of all, absorbed residues are just what they sound like. They're elements of things that were in containers that are absorbed into the surface and matrix of the container. And it can be anything from a meal, a beverage, medicines, paint, anything that was in the container. And this isn't the schmutz that you can see on the inside of a container, it's absorbed into it, so it's not something you see. It's important to remember that everything that goes into a container does not get absorbed into the matrix of the container. Only certain things do, and only certain things actually preserve because of the stability of the molecule, because of solubility. If they're in the archaeological record, then the setting that they're in, what they're exposed to, things can disappear. Believe it or not, bacteria and fungi consume a lot of things in the archaeological record, including things absorbed into pottery. So not everything that goes into a vessel stays there. In order to find these residues or detect these residues, we use a sampling technique called mass spectrometry. And there are a whole bunch of different mass spectrometry techniques that use slightly different approaches, but the basic idea is that it takes a sample, it sorts them into its chemical components based on weight. And it gives you a little printout that has peaks on a graph, and those peaks represent the weights of the different things in your sample. And you identify what's in your sample by knowing what the weight of the element or compound is. And that brings up a really important point. This isn't CSI. I can't stick a sample in there and have it print out a thing that says, Adam, you've got this, and this. It doesn't work that way. In fact, it's almost impossible to do it that way. It'll print out and give you this long list of peaks on a graph, but the only way you know what those peaks are is if you know what the weight of what you're looking for is beforehand. And so you have to know what you're looking for beforehand, because it's virtually impossible to know the weight of every compound that's out there that might be in your sample. So Rather than inductively, this method is best used deductively. You know what you want to look for first, and you tell the machine what it looks like by running a pure sample through it, and then the machine looks for it. So in this slide right here, you've got the standard for atropine. There's your peak. You run a blank through it, nothing there, good, that's the way it's supposed to be. Then you run a sample through, and there's your peak right where atropine should be, and you say, okay, this sample is positive for atropine. So you have to know what you're looking for ahead of time, which if you think it through means you gotta know, or at least have somebody who knows a little bit of chemistry. I'm not a chemist, but my brother is. That means that, and we call these things biomarkers, the things you want to look for. That means that you have to be very smart about choosing your biomarkers. You have to know what's in the thing in the container you're looking for. In this case, we were looking for beverages made using specific plants. You need to know what's in those plants, but you need to know what happens to those plants when you make the beverage. When things get cooked, when things get combined, they change chemically. And you have to know something about what happens to those things after it goes in the ground, because again, fungi and bacteria and all sorts of things can consume these. So you've got to be smart about the biomarkers you choose, otherwise your project isn't going to produce any results, and I'm going to show you a minor instance where we learned that very painfully. Another thing to consider is you've got to get the sample, you've got to get the residue out of the container. And there are different ways to do this. And those ways balance a couple of things. One is how destructive is the method. Because remember, this is something that's absorbed into the container. It's not scraping something off the surface. It's taking part of the container out, in a sense. On the one hand, more destructive, less destructive. On the other hand, what you get in your sample. Because the reality is, containers that have been sitting around for a while are exposed to modern contamination. Probably the most important is dust. You would be surprised what's in dust in terms of all sorts of chemicals, including things that we're looking for as biomarkers. But you can imagine when you're working with museum collections, destructive analysis, that's an issue to be considered very seriously in terms of what you can actually do to an object. So, that was my water sampling. One of the methods, there are two water sampling methods, and obviously these are non-destructive. You put water in a container, swish it around, dump it back out, and that's your sample. It relies on really water solubility to capture the sample, that the water actually dissolves it and breaks it free from the matrix of the vessel. Non-destructive, but it also captures any surface contamination that's in the vessel. You can only do it with whole vessels. You think about museum settings and you're thinking about fabulous objects that would be displayed, but there are lots of things in museums that are fragments or pieces. And you can't do this with something that's just a piece, because you only want the interior of the container. Another method, one that my colleague Terry Powis has pioneered for the use in absorbed residues, is called a Sonicator. My business manager calls it my ring cleaner, because it's a container that you put water in and it vibrates it, and people use it to clean things. In this case, we're using it to vibrate the container that's filled with water, so the wash method, except we're using the vibration to break free some of the residue that's inside the ceramic. As you can see from the picture, it doesn't project that well, it's a bottle, and it's in this container, it's floating on the water, but we've had to develop some elaborate things to make sure it doesn't tip over. So it's actually sitting in a little plastic pan that you put pots on from plants, and it's in a little piece of styrofoam so it doesn't flop over. There were many nervous moments with the curators and collections managers here at the Gilcrease as we floated various precious objects in strange ways like this. Again, it requires that it hold water, and it does capture surface contamination. So these water methods are non-destructive, but you get whatever's there. The other end of things are destructive methods that we call Burr methods. This one, called the grind and burr, works only on fragments. You take a piece of a container, you grind off both of the exterior surfaces inside and outside of the vessel, so you just have the matrix of it, and then you pulverize that. So you're capturing the entire container in a sense, except for the surface, but you just do a piece. So this is completely destructive. but it gets rid of all the surface contamination. I didn't even ask anybody here at the Gilcrease if I could break off pieces of some of these things and grind them up. So you can see where your sampling strategy depends on what you're working with. This is the best at eliminating surface contamination, but the most destructive. Another method that, again, Terry Powis, my colleague, has used in his study of cacao in Mesoamerica and South America, we call the Burr method. And again, it's capturing a physical sample, but you use sandpaper. And you pick a spot on the interior of the vessel and you sand off the surface and you get into the matrix a little bit and you capture it as a solid sample, and that's what you analyze. It's not as destructive, so you can take a vessel, and we did this, sand it, and in terms of display, in terms of function in a museum, you don't really change it all that much. But it does capture surface contamination. You can do this with whole containers, and you can do it with pieces. So it's flexible, it's a little bit destructive, but not too bad, but it does capture surface contamination. All my surface contamination talking, here it is. How does this stuff get contaminated? When it's in the archaeological record, buried in the ground, underwater, it's exposed to groundwater and soil and things like that, and any of that can deposit residues on the containers. And so you can get things that get into it after it's been used. And that's one source of contamination. Another really important one is airborne contamination. And you wouldn't think about it, but some other researchers did some studies. They collected dust samples from a bunch of different curation facilities. They were looking for caffeinated beverages. So they were looking at caffeine, theobromine, theophylline, and guess what they found in their dust? Caffeine, theobromine, theophylline. It's everywhere. It's raining down on everything. Why? Because it's industrially produced and it's consumed on such a large scale that it's airborne, and it's circulated through curation facilities just as part of forced air, and especially things that sit out in the open, on display or in storage, it falls down on it. You can also get it from handling. Now, any museum professional will tell you, you're not supposed to touch this stuff with your bare hands, you put on gloves. But that's not always the way museum pieces were treated, and especially collections that have been around a long time, people have handled it with their bare hands. And a lot of archaeological objects in museum collections come from other collectors that have donated them or sold them. So those objects have a history before they get to the museum that it's difficult to know what happened to them. And you can get a drip of coffee on your finger, touch the inside of a vessel, and the mass spectrometer will pick that up. It's sensitive enough to do that. So, and you can see where some of these things you can account for, and some of these sources of contamination you can't necessarily account for. You don't know it. So that's a major problem, or a major limiting factor. So there's a lot to consider just in terms of absorbed residues. What are you looking for? What are the biomarkers? What methods are you going to use to capture it? What methods are the people at the museum going to allow you to use to capture it? All of that goes into planning just to know what to look for. Now, in this Gilcrease residue study, we were looking for a set of different kinds of plants that we know were used in Central and North America in sort of ritual settings. We looked at some vessels from West Mexico as well as from Arkansas and Oklahoma. I'm not going to talk about the West Mexico stuff because that's 2 weeks. You have to come back for that one. But we looked for the same biomarkers. Of course, one is cacao. We know that was consumed in Mesoamerica. It was an elite beverage. There are some studies that say that cacao came into the Chaco Canyon sites in the American Southwest and up the Mississippi Valley and into the Ohio Valley. So we wanted to see if we could find cacao. Native Americans in the Southeast and Midwest in the past and today continue to make tea out of yaupon holly, sometimes called the black drink, that's a ritual beverage that's used in a whole variety of ceremonial settings. And we wanted to see if we could find black drink. Other studies have argued that they have. We wanted to look for that. Willow is something that contains salicylic acid, which is a major component in the original aspirin, right? It's the original analgesic. And Native Americans were and continue to use willow, the bark, the roots, the leaves, to create beverages that are analgesics, but also, especially in the Southeast, they're consumed in ritual settings as well. So we wanted to see if we could find what they call willow medicine. We wanted to see if we could find flavorings in the cacao beverages. was optimistic, hoping we would find cacao beverages first, but we thought we would look for vanilla. Vanilla was domesticated in Mesoamerica. It comes from an orchid, and we looked for the biomarkers of vanilla. The last one we looked for was Datura. Datura is a genus of plants that produce hallucinogenic properties. They have tropane alkaloids in them. Jimsenweed, loco weed, moonflower, all sorts of different names. We know today and in the recent past, Native Americans use these for different kinds of activities, and we know archaeologically that there's some evidence that they were used. We wanted to see if we could find Datura. So a whole bunch of different things that we were looking for. And here are our biomarkers that we chose, trying to choose wisely, but not necessarily always succeeding. So with the Datura, the jimsenweed, scopolamine, and atropine, with the willow, salicylic acid, the aspirin. For the yaupon holly, originally it was caffeine and theobromine. I put that theophylline in parentheses because the published literature says there's no theophylline in the yaupon holly. If you go down to cacao, it has caffeine, theophylline, and theobromine. So some people use the presence of theophylline to say, I've got cacao instead of black drink. Well, we went back, this is after our Gilcrease study, and we sampled about a dozen different yaupon holly plants, and guess what we found? Theophylline. So we were using the same set of biomarkers to find chocolate and the black drink, and that means we couldn't tell them apart because they have the same biomarkers. So there's your choosing biomarkers affects how your study comes out. And then vanilla, vanillin, and vanillic acid. Our sample was 31 Caddoan and Mississippian ceramic vessels dating from 14 to 1700. They all come from Arkansas, part of Thomas Gilcrease's collection that he amassed over a long time. Most of these were excavated in less than systematic circumstances and sold and then bought by Gilcrease. They're incredible whole vessels. Most of them come out of mortuary contexts, but by today's archaeological standards, they were looted. They weren't dug systematically, so a lot of information has been lost. We chose elaborate vessels. We chose ones that have imagery on them because we wanted to see if the imagery correlated with the residues, sort of labeling the containers. We'll get back to that. We also looked at shell cups. These come out of the Gulf and maybe the Atlantic, and they're traded all the way, all over the place, even to here in Oklahoma and throughout the Mississippi River Valley. We know historically that they were used for black drink ceremonialism, the stuff made from yaupon holly, and we wanted to see if they were used for other things. Another study using the wash method sampled some shell cups, and they didn't find any residues. We wanted to see if our techniques actually found residues. Our sampling strategy was the Burr method with the sandpaper, which works on whole vessels and fragments. We were working with whole vessels. You see me standing there hunched over, hugging that vessel. That was probably another nervous moment for the collections people here at the Gilcrease. But you see that we're wearing masks, we're wearing gloves to capture these samples. And we also used the Sonicator method, put distilled water in the vessel, and here's another example of floating in various things to vibrate it to collect the sample. I'll say that we sampled several different vessels using both techniques, and they both produced comparable results. So they both work. There are some subtle differences, but we need more work to figure those out. We also did the contamination sampling. We collected samples from shelves, from desks, from the photo room, everywhere we could find. And we collected them in two ways. One, just by squirting water on the shelf and sucking it back up and capturing dust that way, and also by taking a cotton ball. The weird thing is that we've discovered cotton balls contain caffeine. Who knew? So contaminating your contamination samples. So we collected both ways. Here are the results in a nutshell. In the contamination sampling, we found the biomarkers that would indicate cacao, yaupon holly, and vanilla. They're in dust. So why is vanilla in dust? Scents and fragrances that are part of beauty products and cleaning products, you're getting vanillin on you all the time. Caffeine, the same thing. Salicylic acid, which would be for the willow medicine, because of its use in different analgesic products, it's mass-produced. These things are in groundwater, they're everywhere, but they're in the dust here at the Gilcrease too. And you understand what that means. Since I'm finding it in the dust, when I find it in a sample on a container, I don't know whether it's a real residue or whether it's just from dust. So that throws out everything I was trying to do with cacao, with yaupon holly, and with willow. The only thing that wasn't in the dust were the biomarkers for Datura. And when you look at the results of the ceramics in the shell, you see this really well. The ceramics, every vessel contained the biomarkers for chocolate and yaupon holly and willow, and most, or at least a third of them, contained the biomarkers for vanilla, probably because of contamination. But only 7 of them out of the 31 contained the biomarker for Datura. When you look at the shell, every single shell had the biomarkers for cacao, ilex, willow, and vanilla. And the only thing we could see was Datura, and 14 of those had Datura. So, here's one of those moments where we came out with a whole list of things we wanted to do, and it got weeded down really fast because of this issue of contamination that we have yet to deal with thoroughly. But let's have a little fun with Datura. We found this, we think they're real residues. Now let's look and see how Datura fits in with the imagery that's on the ceramic vessels, which was really what we were about. Remember, Datura is a hallucinogen. It's used today, it's been used in the recent past. It's used as a topical treatment. It's used when you smoke the leaves for sort of some ritual activities. If you make a tea out of the leaves and the seeds, which I don't recommend you doing, this is really very dangerous. There are lots of people who went on these voyages and never came back mentally. It's something that takes some real practice, and the people that use it are very experienced with it. There are students at universities who experiment with this after taking a class, and it doesn't always end well. But it's a hallucinogen that Native Americans were using. Now, in order to understand the labeling on the vessels, I have to get into the iconography research. Iconography is the attempt to understand, at some level, the meaning of the imagery, ancient imagery. And here we're talking about Mississippian, we're talking about before writing, although we have lots of ethnographic information about what the Native Americans today and in the recent past believed and thought, and we've done a lot of systematic work with the imagery itself. And this is sort of a model of the Mississippian cosmos. And it's pretty common for Eastern North America Native Americans. The world, the cosmos, is organized into 3 realms. There's an above world, which is a dome, and the sun is up there, and other supernatural beings are up there. It's a place of moral order. Everything works right there. This world is the world of people and animals and some spirits. It's a plane floating on the primordial sea, and it's attached to the sky dome at the 4 cardinal directions. It's got some spirits and supernaturals, but it's sort of in between the 2 realms. The beneath world, you go under the water, you go under the ground, you get to the beneath world. And the main supernatural there is the Lord of Death. He's sometimes thought of as a cat monster, sometimes as a winged serpent. He guards the entry to the path of souls, where souls travel when they die. That path of souls is the Milky Way. And guess what happens? At night, the sun sets and the realms switch. So the night sky is the beneath world, and the Milky Way is the path of souls. And the moon is a female figure, sometimes referred to as old woman who never dies, sort of an earth mother figure. So we've got different themes and different beings associated with each of the realms. Now let's look at our ceramics, the ones that are positive for Datura. The picture of the pot is atrocious, but you see the drawing. That's what's on the pot. Do you see a winged serpent there? Do you see he's got a mask, which is actually the cat monster mask? That's the Lord of Death. This vessel has an image of the Lord of Death. This is the guy that guards the path of souls and lives in the beneath world. These 2, again, not projecting, great. It's a frog and a turtle. Where do frogs and turtles live? In the water. What do frogs and turtles do? They go from land and they go down in the water, and then they come back up out of the water onto land. So they're traveling between the realms. So these are things that live in the beneath world and travel between them. This is a female figurine, and there are a bunch of these that are made in a couple of different regions in the southeast. This is Old Woman Who Never Dies. based on a whole series of ethnographic accounts. There's an Earth Mother figure who ages, and then she's reborn. Ages and reborn. The life cycle of everything living. She represents everything living. She's the moon. But she also is the one who helps bring souls back from the realm of the dead. So here's that realm of the dead business again. And then we have this, it's a head. And that severed head figures prominently in a lot of imagery in the Southeast. And we think that's a character, it's a creator being. It's first man. He's the sun in the sky. He goes to the beneath world and does battle with some monsters and gets killed and his head's chopped off. His kids go down there, they take his head and they bring it back. And his wife, old woman who never dies, brings him back to life and the sun goes back to the sky and everything works. He brought back with him the ability to bring souls back from the dead. So here's another one that travels to the realm of the dead and comes back. This is a bottle that has a set of swirls with snake-like markings on it. I'll just pantomime it since it's probably not going to project very well. But the whole idea of swirls, we think iconographically refer to whirlpools, and they refer to an entrance to the realm of the dead. So you go through that sort of an entrance. So it's the same kind of idea, referring to the realm of the dead. So we have a theme, right, of all of these vessels. They are beneath world figures, which is where the souls of the dead go. And they travel from this world to the beneath world, and several of them come back. All of these vessels were found in burials. So there's an association between this hallucinogen Datura, graves, and people who go to the realm of the dead and come back. So this is about mortuary rituals. So what did we learn? We learned that Datura may have been used in the past in part of mortuary rituals that have to do with going to the realm of the dead and coming back. The shell. To reinforce that just a little bit, the shell containers all come from the spirocyte right here in Oklahoma. They come from two very special contexts. That's called the Craig Mound, that three-lobed thing. And in that, there were some very special mortuary settings. One of them was a big communal mortuary setting where they would periodically lay out objects and people in a whole setup. It was a ritual more than it was just a funeral. And they would leave it for a long time, and then they would clear it out and put a new one in. And those shell cups occur in that setting. At some point, they pushed all that aside and they built this clay cone that created a chamber, a hollow chamber that was covered by that tall mound right there. And in that cone are laid out in a circle a whole bunch of copper objects, shell objects, statues. It's a ceremony that's laid out and sealed in place in this cone. And those cups were in there too. Now the problem is that this site was largely investigated by a group called the Pecola Mining Company, a group of men who rented the mound, tunneled into the side, and dynamited it. And they just pulled stuff out and sort of fought over what they got, divided it in piles, and each took their pile and sold it. So we've lost a lot of the context. But we know it's these special burial contexts. So the shell, 14 of the 19 shells came back positive for Datura. Most of them are undecorated. There are a few that are. Only this one really has imagery we can see very well, and it's a couple of entwined snakes, and snakes are denizens of the beneath world as well. The shell itself, where does it come from? It comes from the ocean, so it comes from the watery beneath world. So again, we've got this association between Datura, the beneath world, and mortuary settings. So what did we learn? Well, we learned that you need to be careful with your biomarkers, and we learned that you need to pay attention to contamination and do your best to try to work around it. And it's not always possible to do that. And what we learned from the Datura is that based on archaeological context, iconography, and the presence of that residue in those pots, that in the past it was probably used as part of rituals that have to do with people being buried and probably in some sense ensuring that those souls come back to the community and come into a new body. Now we still have the samples from the museum, what we collected at the museum, so we can continue to do more analyses, and the obvious first thing to do is to go back and choose some biomarkers that aren't in the dust and try to look for some of the other plants that are out there. And I've been cut off. I guess my time is up. Thank you very much.